Another type of limit that could potentially give us the indeterminate form would be one involving a radical. So in this case, if I plug in 0 for x, I'm going to end up with root 3 minus root 3 on top, which would give me 0 on top, over 0 on the bottom. That is your indeterminate form, which says there probably is an actual answer for this limit. You're just going to have to do more algebra to actually find it. So in this case, I need to eliminate the radical because that's what's causing the indeterminate form here. In order to do that, we need to rationalize the numerator because that's where the radical is located. And to rationalize something, you always multiply by the conjugate. Now remember, the conjugate would be the same thing as what I have in the numerator in this case. So x plus 3. But I want to do the opposite sign as what I see in the middle. So this one's subtracting. So the conjugate would be adding. And then I keep that root 3 at the end. And whatever I multiply to one side, I need to multiply to the other. That way I'm not actually changing anything mathematically. I'm just multiplying by 1 in disguise. That way I can manipulate it to actually simplify, get rid of the indeterminate form, which is at 0 over 0, and find the actual limit. So if I go through, I'm going to FOIL the top because I have a binomial right here times a binomial. This will leave me with x plus 3 minus 3. Still have that limit notation out in front because I have not actually plugged in the 0 yet to evaluate the limit. But I am not going to distribute the denominator because I'm hoping something's going to cancel the next step. So I'm going to keep that x that I have written in blue in front of the parentheses with everything that I have in green, which was your conjugate. So x times root x plus 3 plus root 3. Now I want to see if I can simplify anything. Notice in the numerator you have 3 minus 3, so I can go ahead and cancel those. Now I have x over x, so those cancel as well. Now that those are canceled, I'm going to go ahead and rewrite what's left over. So I have the limit as x is approaching 0. There's an implied 1 on top since everything else is canceled out, over what I have in parentheses, root x plus 3 plus root 3. Now that I have simplified my fraction, I want to go ahead and evaluate my limit. So now I'm going to actually plug in the 0 and see what I end up with. So in this case, I end up with 1 over root 0 plus 3 plus root 3, which is going to give me 1 over root 3 plus root 3. Those are both like terms, so because those root 3's are exactly the same, then I end up with 2 root 3 in the denominator. So the y value that this original equation on a graph would go to as x approaches 0 would be the y value of 1 over 2 root 3, which is the definition of a limit.